company is moving up. To reach for leadership in the design and development of advanced radar electronics, electronically steerable microwave antennas, and lightweight structures for space. The facilities. The experience. And the talent. Ryan has it. The complete capability for the design, manufacture, and test of airborne and spaceborne electronics. For 17 years, Ryan has delivered radar sensor systems for more than 35 different types of helicopters, aircraft, and spacecraft. In space, 6 Saturn rockets carried Ryan radar altimeters. The 5 surveyors that soft landed on the moon were guided by Ryan radar sensors. The Apollo astronauts will depend on Ryan radar to control their lunar module as it slips from orbit around the moon and descends under radar and rocket control to settle safely on the lunar surface. Benefits from these space programs are being directed into Ryan airborne navigation systems. Ryan's AN/APN 182, a Doppler navigation system, is going into Sikorsky's new SH-3D anti-submarine helicopter. Using an advanced frequency tracker, this new radar eases the helicopter into an accurate hover, permitting safe and rapid sounding. Advanced electronic components are also a feature of Ryan's AN/APN 192 radar altimeter. This system provides pilots with warnings by both sight and sound of flight below preset limits, low altitude, or of descent too rapid for safe landings, high sink rate. Successful evaluations have been conducted, including one with an advanced rigid rotor helicopter. This is truly a precision altimeter. Analysis of airframe fatigue is extremely important in flight safety. A compact Doppler sensor weighing only 4 pounds measures impact velocity at touchdown. The system is Ryan's AN/APQ 135 sink rate radar, which has won its wings in evaluation aboard Navy carriers. Air Force evaluations of the sink rate radar have also been conducted this summer. Experience with hardware for space also helped in the designing of Ryan's AN/APN 193 Doppler navigation system. The 193 makes use of a narrow profile antenna that mounts flush with the fuselage. Over a 2,000-mile course at altitudes up to 70,000 feet, the 193 has tracked aircraft velocity to an accuracy of 1%. Every surface of land or sea reflects radar in a different manner. Each surface has its own radar signature. Transmitting a narrow fan beam, Ryan's patented Doppler radar scatterometer records reflected radar signatures at all angles simultaneously in one pass over the target. A prime application is military site selection. The all-weather sensor sees through cloud cover, operates both day and night. As a sea state sensor, it has indicated wave height and distribution, wind velocity and direction. Waves as high as 29 feet, sea state 7, have been measured remotely for the first time. Application is seen in aerial weather observation and in more precise charting of typhoons and hurricanes. Instrumented Earth orbital satellites can observe global sea state conditions. The Ryan microwave radiometer is another remote sensing device. It measures the natural temperature, or radiation, emitted by all objects. In this way, differences in soil and vegetation types can be detected remotely. This is an all-weather sensor that peels back both cloud cover and darkness. Reconnaissance applications are readily apparent. Since it is a passive receiving instrument, enemy forces would not be alerted to its presence. Phased array antenna systems, electronically steered, solid state. Backed by 3 years of advanced research and development, Ryan has simplified the design and reduced the size of these steerable microwave systems. The arrays are composed of small, lightweight, solid modules, each an individual antenna, complete with transmitter, receiver, and processor. Physically, because of the individual modules, the antenna array can take a variety of shapes for conformal mounting. Current applications include acquisition and tracking radar, communications data link, and missile target seeking. Demonstrated beam coverage is 140 degrees. Scan time is 1 million times per second. Sensor information is in real time. Action of the steered beam is multi-directional. Several targets can be tracked at once. Related functions can be combined in a single array. Ryan's fast-action multifunction antenna systems will reduce the number of antennas now required for military aircraft by a factor of 3 to 1 and will assist in the realization of truly multi-mission satellites. Ryan Space Structures engineers are producing advanced roll-out solar arrays that offer large areas of solar cells at light weight. This 50-square-foot prototype array has undergone rigorous environmental tests. A 250-square-foot array has been fabricated under contract. Principal breakthrough in Ryan's rollout technology is this collapsible titanium structure. It is the support beam for the rollout panel. It is the mast of roll-up antennas being developed for the Army. It is the gravity gradient stabilizer in this conceptual satellite. Ryan's rollout structure can be a deployable truss. The truss, coupled with Ryan's advancing technology in microwave antennas, could make possible a large electronically steered antenna, one that rolls out in space, transmits or receives, serves as a military intelligence data link, or as a direct broadcast communicator. By adding a second truss, the structure becomes a deployable box beam. And finally, for global communications, a large self-erecting log periodic antenna, or even a huge parabolic dish antenna, constructed in space. Lightweight structures for space. Solid-state microwave antenna systems. Remote sensors and radar electronics. Ryan is moving up.